Hi, hello, this is Jenny. So, today's topic is number system in digital electronics. Okay, so last session we have covered decimal number system. Okay, so how to convert decimal to binary. Okay, and octal to binary. Okay, base is 8, and next hexadecimal to binary. Okay, so we want to see this decimal to hexadecimal conversion. This full we covered decimal number system. Okay, right. Next, binary to octal conversion. In binary to hexadecimal, binary to decimal conversion. Okay, now let's see binary. Okay, so previous session we see decimal number system, decimal to binary, decimal to octal, decimal to hexadecimal. Okay, so if you want to convert decimal to binary, you should use base 2. Octal, decimal to octal means we should use 8, base is 8, and decimal to hexadecimal means we should use the base 16. Okay, so next let's move on to binary number system. Okay, so this number system is mainly used in our circuits. Okay, when we are using this gates, for example AND gate, OR gate, NOR gate, NOT gate, empty, all the circuits checking, we are using this conversion. Okay, so binary. Now binary to decimal conversion. Okay, so they given the binary digits to you, and then you should convert the whole number. Okay, so what is the whole number of this binary bits? Okay, so here you can see how many bits. 8 bits. Okay, so 8 bits is equal to 1 byte. They given 1 byte value, so we should find the decimal value. What is the value of this 8 bit? Okay, next, if we want to convert from binary to decimal, we should apply this formula or methodology. Okay, so the base is 2. Okay, so for decimal to other number system conversion, we should apply this divide method. Right, now for decimal to any other number system, we should apply this divide method. Now binary to any other number system, we apply this multiplication method. Right, so here we are using only two methods, divide and then multiplication. Multiplication here after we should add that digits. Okay, right, so here you can see this is the first example for binary to decimal conversion. Here they given some 8 bits, so I'm going to split this value from right to left. Okay, so right least corner and leftmost corner, I'm going to take this value. We can apply this power. Okay, so for example the base is 2 because I'm going to get the decimal value. This value is in binary, that's the reason I'm using this radix 2. So here you can apply this power, you can calculate from here. This power is 0, 1, 2, 3, 4, 5, 6, 7, right? So your values up to 7. Okay, that last value of the power is 7. So now we can make this value from right to left methodology. Okay, right to left corner. So 1 into 2 power 7 plus next 1 into 2 power 6, another 1 into 2 power 5, next 0 into 2 power 4, 1 into 2 power 3, another 1 into 1, 1, 0, 1, again 0, then 1 power 1 into 2 power 1, another 1 into 2 power 0. So if we multiply anything power 0, you will get this power value is 1. Okay, you multiply with in 0, you will get that answer 1. Okay, so now we can calculate 2 power 7 is 128, right? And 2 power 6 is 64, and 2 power 5 is 32. Then 2 power 4 is 8, plus you are going to multiply that value with 0. If you are multiplying with 0, you will get the same answer, 0 only. Okay, right. So that my answer is here 0. Next value is 2 2s are here 8, right? So this value is 0, here 8. Again, you are getting this value 0, then 2, and the last value is 1. Okay, so 2 power 0 is 1, 1 into 1, 1. So now we add all these numbers, 128, 64, 33, 8, and 2 plus 1. So you will get that answer 235 base 10. So this is the value of binary to decimal conversion. They given this 8 bit. This 8-bit value is 235. Okay. So now we can split this value from, again, reverse conversion from decimal to binary means we can split like this: 5, 3, 2. Now we calculate 5 value is 0, 1, 1, and 3 value is 1, 0, 1. Then 2 value is 1, 1. We can see here 5 value is 1, 0, 1. Next 3 value is 1, 1. Okay. And 2 value is 1, 0. Okay. So 3 value is 1, 1. 1, 0. Okay, 1, 1. You can get that value. Okay, 2, 3, 5. So we can get that bit, 8 bits. So this is the conversion of decimal to binary. Okay, let's see one by one. Now we are focusing this binary to other number system conversion. Okay, and next. Next one is octal to decimal conversion. Now we have the binary to decimal conversion. Next, we move on to this octal to decimal conversion. Okay, so they given this number, octal number base 18247. So now we are going to apply this technique. So that power is base is 2, 8, base is 8. So 7 power 0, 4 power 1, and 2 power 2. Okay. So here you can apply 2 into base 8, 8 power 2, 4 into 8 power 1, and 7 into 8 power 0. So here you can get that answer 7, and then 32 plus 2 into 64 is 128. So if you add that value, 167 base 10. Okay. So the same methodology we can apply here also. For example, octal to binary. a decimal conversion. Octal to decimal conversion. Octal number is, for example, 12. Okay, so 12. How we can convert this? 2 power 0, 1. Okay, so 1 into 2 power 1 plus 2 into 2 power 0. Okay, so now you can get that answer. 2 power 0, 1, 2 into 2 plus 2 power 1, 2. 1 into 2, 2. So you can get that answer 4. Okay, so the 12 octal number, the decimal value is how much? 4 base 10. So this is the conversion of octal to decimal. Okay, and next, binary to octal. Okay, so first we have seen binary to decimal. Okay, next binary to octal. Okay, octal to decimal. Next, one more session. Okay, octal to binary. So octal to decimal we have seen. Next session is octal to binary conversion. So octal number is 247 base is 8. Now we have here, we should split like this: 7, 4, 2. Okay, so this 4, you can get that value 7 divided by 2. 3 2s are 6, remaining 1. 2 2s are 1 2s are 2, remaining 1. So you can get that answer 111 for this A value. Okay, and next 4 also you can get 2 2s are 4, 1 2s are 100. That answer is 100. Yes, right. This one is also right. Next 2. So here you can get that answer 10, but I need 3 digits. That's the reason I am adding this extra bit to the rightmost of the next bit. Okay, so 010 is my 2 values binary value. Now I am going to add all these numbers: 0 1 0 1 00 111 base 2. This is the answer of this octal number 247. Here base is 8. If 8 means this number is octal. If you are putting base 2 means this number is binary. So the binary value of this 8 bit, the answer is 247. Okay, so this is the conversion of octal to binary conversion. And next, octal to hexadecimal conversion. Okay, so here you can see octal number is 55456. Okay, so base 8. So same thing which have applied right now. Okay, so I am going to split like this: 6 4 5 4 5. Okay, so now you deduct that binary value. Okay, what is the value of binary value of 6? How we can do for 6 means we can do like this: dividing method. Okay, 3 2s are 6, remaining 0, and 1 2s are 2, remaining 1. So the answer is 110, right? Okay, and next 5 we can get that value, and 4 also we can get this 100, and 5 value the same thing. So when I am going to join this all bits, okay, here you can get that how many bits: 3 6 9 12 bits. So here you can get that 12 bits of binary digits of hexadecimal value 5456. Okay, and next This is for the conversion of octal to binary. Next, binary to hexadecimal. If they are given the same value, okay, so this is your binary value. Now we are going to find out the hexadecimal value. So we have to find the hexadecimal value, means we have to split the bits 4 digits. Okay, 4 bits we have to split this, because already I'm having 12 bits, so that's the reason I'm going to split 4 bits, right? Yes. So now we calculate that 4 bits. How we can calculate? For example, 0 1 0 0. How we can calculate for this binary, okay, or hexadecimal? How we can calculate? 1 1 1 0. Okay, so 0 power is 0, 1 power is 2, 1 2 3. So the base value is binary to hexadecimal 1 1 1 0. 1 into 1 power 3 plus 1 into 1 power 2 plus 1 into 1 power 1 plus 0 into, okay, sorry, base is 2, 2 2, okay, 2 power 0. Okay, so here you can get that answer 8, here 4, here 2, right? So now we calculate this value. 8 plus 4 plus 2, 10, 10 plus 4, answer is 14. So the binary value of 1110 value is, binary value of 1110 value is, the decimal value, hexadecimal value is 14. Okay, so 14 means hexadecimal value, we don't write this 14. How we can write? A B C D E F. Okay, so this is your 10 value number 10, 11, 12, 13. What is the value of 14? Yes, E. So that is your hexadecimal value. So the 14 decimal value of the hexadecimal value is E. Okay, so now here you can see that value is B2E base 16. This is right. Okay, so this is the conversion of octal to hexadecimal. Next, octal to binary conversion already we have seen. Next, octal to hexadecimal conversion, and then hexadecimal to octal conversion. Okay, so if they are given the value is hexadecimal, for example, we can take that previous example, b to e power 16. Okay, the base is 16. How we can split? We can split e to b. So what is the value of e in hexadecimal? Yes, number 40. 2 2 same. B 11. Okay, so now we can apply this binary technology. Okay, binary formula. How we can find out that binary value of 14? Yes, we apply that division method. For 14 we can get that answer 1110, right? So now we can write all the digits. Okay, so all the 4 bits we are going to make in a single bit, that is 12 bits. Okay, so 12 bits means how many bytes? 8 bit equal to 1 byte, so 1 byte 4 bits. Okay, so 1 byte 4 bits extra. Okay, that is 12 bits. And next, this is for the hexadecimal to octal conversion, hexadecimal to binary conversion. And next, binary to octal. Okay, so they given this number binary, so we have to split. In octal means, octal or hexadecimal, we have to split that number three digits. Okay, but previous session we have seen binary to hexadecimal. Here we can split 4 bits, but when we are moving binary to octal, we have to split 3 bits only, not 4 bits. 4 bits only for hexadecimal, 3 bits only for octal. Okay, so now I am going to split this 3 bits. Okay, from 110, again 101, next 100, again 101, right? So now we can make this binary decimal value. So decimal value means how we can find out this. For example, 110, this is your binary. Now I need decimal value. How we can do this here? So 1 into, here you can apply, because we are going to convert the decimal value now. So the base 2 power 0, 1 and 1 power 2. So 1 into 2 power 2 plus 1 into 2 power 1 plus 0 into 2 power 0. Here you can calculate 2 power 2, 4, here 2. Here you can get that value 1, but 0 into 1, 0. So that value is 6. So 110, that decimal value is 6. Let's check here. Yes, right. Okay, so we applied the right methodology here. Okay, and next we can find out the same like that methodology. Okay, so here you can get that 5, 4, 5. So the total answer of this value is 5456. Octal conversion, that is binary to octal conversion. Okay, and next, already we have seen this decimal conversion, hexadecimal to octal conversion, octal to hexadecimal, then binary conversion. Okay, next, binary to hexadecimal conversion. Binary to hexadecimal means we should split the bits 4 bits. Okay, 4 bits conversion. When we move to octal, we have to split 3 bits conversion, right? This is for octal conversion, 3 bits. And next, okay. So simple, it's a very simple conversion of decimal to other number system, binary to octal, and octal to binary, hexadecimal, everything. Okay. Here also I explain. This is for the hexadecimal to decimal conversion. Hexadecimal to decimal conversion means here we can write that number. For example, E value is 14, B value is 11, then 4. Okay. So now here you can apply, because we need, what type of value we need? Hexadecimal to decimal conversion. Okay. So decimal conversion means we should apply that multiplication methodology. So base is 16. Okay, because that value is in hexadecimal, so that's why I am using this base 16. Okay, so here you can split that value 0, 1, 2, 3, right? So 8 into 16 base 3, and 14 into 16 power 2, then 16 power 1 and 16 power 0. So 16 power 0 means 1, 4 into 1, 4. You can get that answer. Next, 16 power 1 value is 16. 11 into 6, 176. Next, 16 the value we can calculate, and then we multiply that previous number. Okay, so here you can get that value 36532 base 10. That is the conversion of hexadecimal to decimal conversion. Okay, it's a very easy thing. Okay, so where we are applying this digital electronics. Okay, in real time we can see lots of places. Best example I can say, if you are moving or if you are driving in the city, so all the people, we have to wait in the traffic signal. Yes, right? Yes. The traffic signal which is made by this digital electronic circuits, digital electronic methodology. Okay, so that output they displays that LED lights. Okay, so all the circuits made by this digital circuits. Okay, so digital circuits means here you can see this output. Okay, so how the output will come by using of this gates circuits in digital boards. Okay, so here the digital board is decimal 0 to 9. Decimal means 0 to 9. We are going to give the output. Okay, so input 1, input 2, and then output A, B, C. We are going to get 6 types of almost 1, 2, 3, 4, 5, 6, 7. Okay, 7 types of outputs. Okay, so here I'm going to give 4 bits. Okay, 0, 0, 0, 1, 1, 0. That means first two position is off position, another one is on position, and third one is terminal. That means input one input is off, another input is on. Other fourth stages both inputs are on. Okay, that means high low, okay, on or off. So that methodology I'm going to apply here, and then I get that display pattern. You are seeing that digital pattern. Okay, so digital means that value should be like this signal, correct? So if when we move to up means we can get that value 1, that is on position. If it is go down means we can get that value 0, off position. So that number panel, number system designing you can make in this digital board. So that LED light displays is 0, 1 when we are giving this output. Okay, so if I given that both output is on or both output is off, I will get that output like this design or pattern. Okay, so this methodology we are applying in traffic signals. Okay, so traffic signals, what they will do, first they will put red, next yellow, third stage is green, right? Red, yellow, green. See here I am setting that circuit table. Okay, for example, if I given the both input, here you can check that output. Okay, this is my input. Both first I am giving that condition, both conditions is off. That means 0, 0. Next condition is only one input is on. Okay, so that stage is on. Another stage is my first input is on, second input is off. Okay, that is 1, 0. Last stage is both inputs are on. Okay, 1, 1. So that time if both the stages off means the red light only blinking, right? Then if I give the second stage, okay, second panel or second terminal on means first terminal is off, second terminal is on means I can get red and yellow. Okay, so red blinking slowly and yellow is blinking very bright. Okay, that means the ready stage, first stop stage. Okay, red means stop, and next yellow means ready stage. Okay, so I'm going to give this symbol or gestures to the public. Okay, so the traffic signals working like this by using of this digital circuits in digital electronics methodology. Okay, so now as a computer, the system, as a developer, I'm going to write this, make or write this circuit. Okay, not write this circuits, not writing a program. Okay, coding like this, and then I'm going to make the circuit like this methodology, on or off methodology. Okay, so that all the circuits I'm going to give that connection, then only that LED light is blinking or not blinking. Okay, so next stage is first terminal is on, second wire is off means you can get that moving stage, that is green light. Okay, so green light is going to blink. Okay, so green light is going to on. Okay, so that stage is third stage, and fourth stage is if both inputs on means you can get that yellow light. Yellow light means you should be ready. Okay, so this type of methodology and techniques we are applying in the real time. So traffic signals and display boards, even when we are traveling in the train display boards and metal detectors and bus display boards, okay, all the transport display boards, even shops, they are providing LED lights, okay, and then some digits. They are showing digits with the design technologies, that methodologies, full and full on or off mode, okay. That circuit is terminal on, terminal 1 and terminal 2. That means on mode, off mode. Okay. So when I give the inputs both on means it will on. When if I give one input as on, another input is off means only one input, one output you will get. Okay. That is one light is on, another light is off. Which means I'm going to make the circuits like this pattern. Okay. So all the LED lights, banners, displays, everything. Okay. So digital clocks, smartphones. Okay. So all displaying methodology we are making by this digital circuits board in digital electronics system. Okay. So this is the benefit of this. Okay. Thank you so much, Sanjay.